Hi guys, in this new episode I will show you how you can start programming the driver control using Lightning. There are a lot of different driver control configurations, so in today's video I will show you each configuration and how you can start programming. Programming the driver control is very important because it's the configuration that your driver will use during the competition, so it's important to choose a configuration that is good for you and for your driver. One thing that is very important is that you need to have declared your chassis. So if you don't know how to declare your chassis, I will let you a link to that tutorial right here. Oh, I think that right here. I don't know. Welcome to our Lightning example project. We need to go here to the main CPP file and then go right here in this function that is called up control. Basically, in this function is to program the driver control period, so it's important to be here. Basically, the function that we use is in this while true loop. That's because we need that the function start running several times in a loop. So basically, the first step is to go in here to this function. Basically, with the time drive configuration, you control your chassis using two joysticks. With the left joystick, you control the left side of your chassis, and with the right stick, you control the right side of your chassis. So for example, you want to move forward, just move both your joystick to forward, and you want to go reverse, you just need to pull down your joysticks. To program the time configuration, you just need to go here and type the name of your chassis. In this case is my chassis, then point, and then use this tank function. Then the first parameter will be your controller. Basically, in this example, the controller is called master, so you just need to put master right here. And with that, basically, you already have the time drive configuration in your chassis. In the left arcade configuration, you can control the entire chassis just using the left joystick. So for example, if you want to move forward and backward, just move your joystick during the y-axis, and you want to move some nice turn, just move your joystick to the x-axis. To program the left arcade configuration, basically the thing that we need to use is to use the arcade function. So basically go here, my chassis, then arcade, and we need to set the master. Basically the default configuration is using just the left configuration. On the other hand, through the right arcade configuration, you control the chassis using the right joystick. And basically it's the same as the left joystick, but basically now you can control just using the right joystick. If you want to program the right arcade configuration, you just need to go here, comma, and then Lightning, chunk OP arcade. Then we need to choose the configuration that you want, so in this case will be the right. With this, basically you're having the right arcade configuration in your chassis. The double arcade configuration allows you to control the robot forward and backward direction with the left joystick y-axis and control the turning direction with the right joystick x-axis. If you want to have the arcade configuration using double joystick, basically just go here and instead of using right, just type double. When the robot moves too quickly, controlling the chassis can become challenging. To address this, you can adjust the rates to modify the joystick output, which will help slow down the robot. For instance, you may want to reduce the sensitivity for turning while maintaining the same output for forward and backward movement. This feature can be added to the different arcade configuration using the arcade function with all the parameters. So for example, we can add the power rate right here. In this case, we want to keep the same amount of speed in the forward and backward direction, so we can put like a 1. And then we want to limit the output of your motors when the chassis is turning, we can add basically a rate that will be like a decimal. 1 will be the default, like the 100%, and you can add some decimals that will be the rate. For example, the half of the power, or maybe 0.75. So with that you can add some rate for the turning and make your chassis more easy to drive. You may notice that simply using rate is not the most effective way to control a chassis. This is because applying rates always reduce the roll velocity. In short, you will never fully utilize your drivetrain while using rates. However, this is a different approach that allows you to have more precise control while using the 100 of your chassis power. To achieve this, we use the following equation. This function smooths the joystick input based on a specific exponent and maximum value. This mounting function adjusts the joystick value to create a more gradual response. If we apply the equation, output we get this. You may notice that as we increase the exponent, the output becomes smoother. Additionally, if the exponent is an even number, the output function will be preload positive. However, don't worry, in the template you can use odd or even numbers without any issues. Well, and how you can use that function? Basically using the arcade exponential function. Basically, you go here and type my chassis, then arcade exponential, put your controller and then the configuration that you want to use, maybe the left joystick, right joystick, or double. So basically just going here, I will set this for the left, and then we have these parameters that basically will be the exponent for each joystick. For example, for the X direction, that will be basically the turns, and the Y direction, that will be the forward and backward direction. So we can add some number right here. For example, for turns we want like a more smoother reaction that maybe could be 2. For this we can do basically 1, for example, and you can use this function. So with that established, you basically can add a different exponent for each axis, and you have a smoother output for each axis. So for example, if you want to have a smoother reaction for turns, basically you need to increase this variable, and you want to increase the smoother function for forward and backward direction. Basically you can add or modify this value. Most of the common situation is that just for a turn you add a smoother function, and for the forward and backward basically you set to equal to 1. If you want like not using the smoother function, basically you can just set 1 to 1, or use the previous example as told you, that is using just the arcade function, just like this. And there you go. Thing that I forgot to mention to the previous videos is that basically how you can upload your program to your chassis. So basically the first thing that you need to know is basically I always have this option like autosave, because if you don't have autosave, basically you can make some change and you notice like this white circle, that means that your project and this file is not saved. So to save that, just hit Ctrl S, and then you see that this white circle disappeared. Basically the first thing that you need to do is to compile your first project and then upload. To make that, basically just go here on the plus icon, open the internet terminal, and then basically you just need to type make, and basically that will compile all the project and see everything is okay. If you see basically everything is okay, and then you are ready to upload. So basically to upload, just type upload, and well, basically before doing this, connect your brain to your computer using a cable, and then just hit this command. For example, in this case I don't have the V5 brain connected to my computer, but you have, basically you will have here a writer tell you to basically successfully upload your program to the V5 brain. The important thing is that you need to save your program, because for example if I change this and then I try to compile, you will find that the compilation say there's nothing to be done for quick, but that is because I'm not saving this file. So it's important to save the file every time that you want to compile. So for example, then I save it, and then I hit make, and now it's really compiling. So basically if you don't save your file, this program will not upload to your V5 brain, and maybe you are seeing like, I'm making some change and the robot doesn't have that change. So basically it's because of that, because you need to have your file saved. However, the thing that I say, everything that start programming is to activate this option. Basically without to save, it doesn't matter, the change that you're making is saving automatically, so it's like more easy. So don't worry, so just activate this autosave and then run make and upload. One tip that you want to do is just type make and then semicolon and then upload. Basically the command will execute make and then upload in the same time. So basically here is compiling, and then we'll upload will run this command uploading your program to your V5 frame. Basically, you can start using all those functions that I showed you before and start playing with it and finally select the best configuration for you. In addition, you can start programming and making some logic to maybe have a custom configuration by your side. For example, maybe you are interested to program a program that maybe you hit some button, make your chassis slower, and then when you hit back that button, your chassis will run at the normal speed. So you can start playing, you can start using some logical using pros. So let me show you a short example. So back in our project example, we make a program that basically when I hit the button A, will make my chassis slower for turns, and then when I hit again, will return the same velocity. So well, I can create a variable basically to call a slower mode. I will initialize in false basically, and then I can use some function in pros that is called using the controller get digital new press. This basically is for when you toggle a button, and then I will say what button I need. Basically I will use the button A, and when I press this button I will change the variable. I think that is here. So basically this variable starts in false, and then when this will happen I will change the value of this variable. So instead of being false will be true, and then if I hit again instead of being true will be false. I will add a else statement just for safety. I think that is not important, it's not like necessary, but I will add it in that way. And then for example I can add like some turn rate. I will initialize in 1, and then basically I start making like if slower mode is false, basically the turn rate will be 1, but if the lower mode is true, I will reduce the turn rate the half of the power. I need to make this variable a float. So then in using this function I will just the power rate will be 1, and the turn rate, instead of being a raw number, I will put a variable, in this case turn rate. So basically when I hit the button A, I will be in the slower mode being true, and when the slower mode is true, basically the turn rate will be half of the power, so the turns will be more slower. Then if I hit again the digital A, basically the slower mode will be false, and the turn rate will be 1, and the turns will be at the same velocity like the normal velocity. So in this way you can start playing with your logical, and you can make like some of these things. So just keep that in mind, that you can, if you're very creative, maybe you can have some functionality with the buttons and change the configuration of the drivetrain. Well, that will be everything for this tutorial. Thank you for watching and staying here. If you have some doubts or questions, don't think about it, just hit a comment in the comment section. Also in the follow tutorial I will show you how you can start using a programming autonomy routine using a PID functions to move your chassis. So stay tuned for more tutorials. Thank you.